Hi, welcome back. Let's study now the magnifying lens. A magnifying lens is a simple convergent lens. It provides to the eye a virtual and direct image of the object that is seen under a greater angle than it would without the aid of the lens. To be in the conditions for this, the object to be observed needs to be in a plane between the focal plane and the actual lens. If we want to observe a near object without any instrument and we want to get the maximum information of it, the maximum detail, we need to observe it as closer as possible to capture all the details. So it will show the largest possible angle, but there is a limit. Beyond a point we won't see clear. So we will choose as reference distance of observation without the aid of an instrument 25 centimeters. To observe an object without the lens, we place it at 25 centimeters and we'll observe it under an angle alpha naught. To observe it with the aid of a magnifying lens, we want the same object y at a point O such that the virtual image y prime is formed at 25 centimeters from the magnifying lens. Under this condition, we assume the eye right with the lens at h will see the object under an angle alpha m. In this case, we define the angular magnification as the ratio of the angles alpha m over alpha naught. After the scheme, this is h over s over h over 25, which is 25 over s. If here we consider the lens equation, 1 over s plus 1 over s prime equal to 1 over f, if I multiply all by s prime, assuming s prime is negative 25 as it is a virtual image, then I get this as the magnification of a lens if we use 25 centimeters as the reference distance, and the distances are measured in centimeters. Something interesting to do is to put the object at the focal point of the magnifying lens. This way, the virtual image would be at infinity and all rays coming from the virtual image would come parallel at the same angle. This will also help relax the eye as it wouldn't need to do extra effort to accommodate. From the first equation we then obtain an angular magnification of 25 over f. This is the magnification that you will see when you buy a magnifying lens. A magnifying lens with 25 millimeters of focal distance has a magnification of 10. Look that this is not the maximum possible magnification.